Alright, so today we're talking about quadratics, and I've already had it pre-written here because it's organized, so I'll just explain how I got everything. When you see the following words, it means to solve. Zeros, solutions, roots, x-intercepts. Remember that when we write our solutions on the regions, they want us to write our solutions like this. X equals some number, and x equals some other number. It's just safer to write x equals rather than coordinates, just based on what we've seen them take points and add points to. So the methods to solve a quadratic function are quadratic formula, factoring, then setting each factor to 0, graphing, where we're looking for the x-intercepts, or using the table, where we look for where y equals 0. So in the first one, find the roots of the function f of x equals x squared minus 13x minus 30. I start by using factoring. I also show the graphing and table method in case you want to see both side by side. So for factoring and solving, to factor, the first step is to multiply the first and the last term. X squared times negative 30 is negative 30x squared, and the sum has to be negative 13x. That's what I got here. And then I found the factors of negative 30x squared. So I got negative 10x and 3x. Add those up. I got negative 7x. Didn't work. Negative 15x times 2x gets me negative 30x squared. And when I add them, it's negative 13x. This is the one that I need. So then I expand my expression using the two new factors to replace the middle term. And then I did the reverse distribution. So here's reverse distribution, where I found the GCF of this side, which was x. And then I factored it out and then got x minus 15 on the inside. GCF on the right-hand side is 2. Factored it out, wrote it on the outside of the parentheses. And then I was left with x minus 15. There's a common binomial of x minus 15, so it means that I'm on the right track. X minus 15 is one factor, and then x plus 2, the GCFs, are another factor. Set them equal to 0. Now I set x plus 2 equals to 0, inverse operations, and I get x equals negative 2. And then same thing on the right-hand side here, got x equals 15. We write our solutions as x equals as the x values. When I did this on the graph, I got the same solutions, and that would make sense. That would mean that I was on the right track. When I graphed it, this is what the graph looked like. It crossed the x-axis at negative 2 and 15. So my two solutions are x equals negative 2 and x equals 15. For the table, second graph, I looked at the second graph, and I got that x is equal to negative 2 when y is 0, and also x equals 15 when y is 0. So that's how the solutions are written. See, there's 3 ways here alone that we found the answers. The fourth way is the quadratic formula, and I demonstrate that here with this equation, x squared minus 8x equals 24. In order to solve using the quadratic formula, we have to first set the function equal to 0. So I need to subtract 24 on both sides. Then I get x squared minus 8x minus 24 equals 0. The next step in the quadratic formula is to find a, b, and c. A is the number in front of x squared. So in this case, it's not there, it's 1. B is negative 8, c is negative 24. Make sure that these are accurate, because if any of these misses a negative sign or has the wrong sign or is the wrong number, that will completely throw off your quadratic formula solutions here. So here's what I did. I plugged into the formula. Everywhere there was a variable in the formula, I used a set of parentheses. So negative b plus or minus the square root of b squared minus 4ac times all over 2a. And that's what I did here. Negative b, which in this case was negative 8. Plus or minus the square root of b squared minus 4ac all over 2a. I plugged in those a, b, and c's where they belonged, and then I simplified each chunk separately. So negative 8, look at how I circled it here in brown, is positive 8. Let's rewrite it. We're cleaning it up. Underneath the radical, I typed that straight into the calculator without the radical, and I got 160. 2 times 1 is 2. I wrote that down here. Then we split up our answers into the two solutions because that's what the plus and minus symbol means. It means there's a plus solution and then there's the minus one. So we can write it just like this. These are our solutions. I forgot to write x equals. So I'm glad I'm here now. X equals this and x equals this. The reason why I didn't write it as a singular number is because the square root of 160 was actually a decimal. And to preserve accuracy, I want to keep it as the square root of 160 versus writing out a shortened decimal, which would not be accurate. So that is our final two solutions for this function here. Next page. Find the zeros of the function y equals x squared minus 6x plus 2 by completing the square. So I crossed it out and wrote vertex form because that's how we learned it. I'm going to show you how to first rewrite it in vertex form, and then we're going to take that vertex form to then solve the quadratic. So in vertex form, we have to make sure that instead of setting it equal to 0, we need to set the function equal to the constant. So here, x squared minus 6x plus 2 equals 0 is now equal to 0, but I need to move that constant, the c term, over to the other side before I can begin. So subtract 2 on both sides, and I get x squared minus 6x equals negative 2. Then the next step I did was I added box squared on both sides. And what goes inside that box is that b term, negative 6. B term is negative 6. And then I divided it by 2. Negative 6 divided by 2 is negative 3. So I plug that in to my box squareds. Okay? And then I simplified. On this left-hand side, in order to rewrite in vertex form, we need to know this whole expression simplifies to parentheses x plus that number in the box, negative 3, close parentheses, squared, equals, and then you simplify this side to get 7. If you type that into your calculator using parentheses around that number squared. So that is almost to our vertex form. To get this to vertex form, we subtract 7 on both sides, right? And then it would be x plus negative 3 parentheses squared minus 7 equals 0, meaning my vertex is negative 3, 7. Negative 7 is my vertex. Now, to solve using vertex form, I take that equation and try to solve for x. So I take the square root on both sides to get rid of the squared. Then I'm left with x plus negative 3 is equal to plus or minus the square root of 7. The plus or minus comes from taking the square root when we're solving. I add 3 on both sides, and my final answer is plus or minus the square root of 7 plus 3. If you were to plug this into the quadratic formula, you would also get these solutions. So here are the solutions, or in this case, they call them the zeros of this function. And lastly, we have a word problem. Jessica and Caroline work at an ice cream shop. The total amount of money Jessica makes per week is represented by this function, j of x equals 60 plus 5x. The total amount of money Caroline makes per week is represented by the function c of x equals x squared plus 46. After how many weeks x will they make the same amount of money? When we see same, it means when are the two equations equal to each other? Or when do they cross on the graph? So explain how you arrived at your answer. So here, it didn't tell us whether to do it algebraically or graphically, so I show you both ways. Algebraically, we set the two equations equal to each other, and then we solve for x. In this case, I notice that it's a quadratic because of this. This is a quadratic equation, which means in order to solve a quadratic equation, I can't just do inverse operations. I have to use either the factoring, the quadratic formula, the graphing, the table, those 4 ways to find the solutions to a quadratic. And in this case, when I simplified and got everything onto one side of the equation and set it equal to 0, I got x squared minus 5x minus 14 as the quadratic function that I'm trying to solve. I factored it, Two numbers that multiply to negative 14 and add up to negative 5. In this case are negative 7 and 2. So I went ahead and took that shortcut and wrote x minus 7 times x plus 2 is equal to 0. Set each piece equal to 0, and I got x equals 7 and x equals negative 2 as my solutions. Now, we can't just think of this as solving for solutions because they're asking us a specific question. After how many weeks will they make the same amount of money? We can't have negative 2 weeks. That's what these x's represent. But we can't have 7 weeks. So based on this algebra, we would say at 7 weeks they make the same amount of money. Okay? Because we can't have negative 2 weeks. So even though 7 and negative 2 were our solutions, it's only 7 weeks because we can't have negative 2 weeks. Graphically, you look on the table and we see that when we type in both functions into the y equals, and we look at the table, at x equals 7, they have the same y values, which means at 7 weeks, both of them will earn the same amount, $95.